Today we're going to be testing out a Lugols solution for electrolyte. Its strength overall is 15%. It has 10% potassium iodine. Potassium iodide and 5% of iodine. Going to use this zinc plate, which is 30 millimeters width, and probably be in the liquid about 40 millimeters. Have a piece of Graphite in the liquid already, and also we'll be testing, not today but after this experiment, a piece of graphite felt as a positive and a piece of graphite felt coated with zinc for 7 hours at 1 volt at 120 milliamps. And then we're going to compare standard running cell, which will be graphite and a zinc plate. So all I have to do is add the zinc plate. The old trusty data logger, if that was sit there. Okay, I'll add the zinc plate. Alright, plates added. We got 1.4 volts. Going to try 50 milliamps and a cutoff voltage of 0.5. Okay, we're at 1.3 with 50 milliamps. And that's a weak solution. I didn't think that would actually work. Being pharmaceutical brand, that's all you can buy. It's a restricted chemical. So, should we try 100 milliamps and see what happens first? That's just a fan on the data logger, nothing to do with the load. I'm adjusting the load now to 100 milliamps. Alright, 100 milliamps, and we're holding 1.2 volts. Right, just needed to tap that data logger fan. I have that wooden spoon just to separate the two plates from touching. So I think we should just leave it at 100 milliamps and see how long it runs for. Instead of 50, well, that's quite strong. Just a graphite at the same width and length as that one. Yeah, I'll get back, see what the data logger says. Oh yes, that was $30 for $33 shipped for 100 mil. I think I used about 50. So that's 50 mils around about. The cell's been running for 45 minutes and it's starting to drop now to 0.7, so we might stop it there. So 45 minutes on that run. The bounce back is alright. I'll give it a charge for about an hour. The colouring still looks the same. Not sure about the colour of the zinc plate. Looks okay. Alright, I'll get back. Cell's been charged up for 1 hour, starting a test. Okay, it's dropped down to 1.2, it's 100 milliamps. Can't see any difference in colour. Alright, we'll see how long we get. If we get 45, that should be alright. Alright, second run was only 38 minutes run time. So I'll charge it up for 2 hours this time instead of an hour and see what happens. Third charge for the cell, it was 3 hours. 2 hours and 20 minutes, not 3 hours. Starting the run again, 100 milliamp load. Fourth run, only 15 minutes after a 2 hour charge. Trying a 50 milliamp run now without a charge. Maybe 100 is too much for it. So half the load looks a lot better. I'll stop it there and charge it tomorrow and then try 50. I'll pull the zinc plate out as well. Right, it's the next day. That's the state of the plate after the run. You can see it did plate up a bit. It's actually less oxidized than up the top there where it was originally in a zinc battery. But I don't know why the reason it stops running. Shouldn't it just keep dissolving and producing electrons? Probably does oxidize. So I'll stick the thing back in here. The juice is still reddish. I don't know the state of that positive cell. That should be right. Nothing should be happening on there. Looks clean. Just that section I pulled out. So it is the basic model of a battery because of the surface area. It's only a graphite foil and a piece of zinc plate. We might see improvements when I replace the graphite foil with the carbon felt and maybe that one too. So I'll keep charging. I'll give it a longer charge. I might increase the charge voltage a bit because it was at 1.5. I might take it to 1.6 and charge it for longer. Fourth charge for the cell was only 50 minutes due to it had a 15-minute run last night after a 2 hour charge. So we don't want to overcharge it. Going to drop the milliamp run down to 50. So half of what we were running on the last 3 tests. Don't forget the cell's only 30 wide by about 40 in length. Not really great surface areas. Power curve for discharge number 4. 35 milliamp hours and 41 milliwatts. So we'll give it a charge and test it again. Oh yes, and the liquid is a bit more clearer. So you can actually see the plate now on both sides. It's a bit darker on a 3-hour charge. It totally does go clearer after a run. Fifth charge ran for an hour at 50 milliamps. The zinc plate after the 5th charge. You can see the zinc building up on it. On the back side it's pretty clear. Sort of clean looking. Sixth run of the cell. Been running for an hour and 13 minutes on a 4-hour charge bar. Can you see where's the camera here? See that piece of zinc? It's not so straight on the edge. It's very clear now along the back of the zinc. So it's starting to consume the zinc. Still pretty dark in there. That will lighten up later, maybe. It did last time. So, right there, right on that edge. It's starting to look porous too off camera when you look at it closely. I was hoping I'd get some more charges, but it's eaten zinc that quickly. So I might have to swap over to these. End of charge number 6, 1 hour and 45 minutes, 89 milliamp hours and 106 milliwatt hours. I've just stirred it up after that run, and I'm going to check, see if it can run again. So it just had a discharge, no charge, just a stirring. The cell just dropped down to 0.8 volts here, and I gave it another stir, and we jumped back up to 1.2 and dropping. So it lends itself well to probably a flow cell, but you don't keep it continuously flowing. So you use a tank at a time or just before it runs out and pump new solution through. So doing that and stirring it a few more times can keep it running. I think might be able to get the solution to go a lot more clearer, maybe, as a guess. Maybe not, because I got the cutoff voltage at 0.7. I'll just demonstrate. I'll stir it now. So if you keep stirring it around, get more of the reaction happening. Okay, that's interesting. It's good to know. I'd have to make a little fuel cell variant. I didn't get back to stir it in time, and it cut off, so I had to restart it, but it's just tagged on to the last clip. So you could make some software when it drops past 1 volt, agitate the liquid electrolyte, and it goes back to 1.2. As you can see there. Checking the colour. Getting lighter, definitely. Both sides. You can sort of see the plate now. Whoops, it's going down past 1 volt again. Just give it a stir. Back to 2 volts. I guess you can turn the pump off. 1.2, I mean. Don't know how you'll do it with charging it, because the voltage and the milliamps stay the same. You could do it by colour. There must be something else, maybe heat, but I've got nothing to measure anything like that. That zinc plate is getting consumed a bit there. Oops, I missed the cut-off time. It will probably stir back up to 1.2, 1.3, no load. It's probably, I'll give it a few more times and then I might substitute these, since we know what's going on a bit with the cell, in the fact that it does consume that zinc plate pretty quickly. That was 6 charges. Alright, charge time for the 5th one was 3 hours, ran for 109 milliamp hours, 58 milliwatt hours, 71. Then for 4-hour charge today for the 6th charge, runtime 145. Not like it was when it was uncharged. The first time we did it, it ran for a few hours. It's on the video, I forgot. Okay, cell size is 30 millimeters by 40, 50 mil of the electrolyte. The percentage of electrolytes, 5% iodine and 10% potassium iodide. Lugols. Alright, I hope you found this interesting. I'll swap over those electrodes and make the new one.